Dear students, நாம இப்போ இந்த வீடியோவில் பார்க்க போகிறது +2 Physics Terminal State Board First Chapter Electrostatics. இது வரைக்கும் இந்த சேனல் சப்ஸ்கிரைப் பண்ணாதவங்க சப்ஸ்கிரைப் பண்ணிக்கோங்க. இந்த டாப்பிக்கில் நம்ம பார்க்க போகிறது electric potential due to a point charge. So you should first consider a positive charge Q which is kept fixed at the origin, and P is a point at a distance r from the charge Q, and that is shown here in the diagram. So here is the positive charge and this is the point which we have to consider, and that point is at a distance r from the origin. Now the electric potential at the point P is given by V equal to integral infinity to r, because we are bringing the charge from infinity to the point r, and minus E dot dr, and that's equal to minus integral infinity to r E dot dr. That you are taking is the equation 1.32. Now, the electric field due to a positive point charge Q is given by E equal to 1 by 4 pi epsilon naught Q by r square r unit vector, and V is equal to minus 1 by 4 pi epsilon naught, that is integral of infinity to r Q by r square r dot dr. So here the infinitesimal displacement vector, that is dr, equal to dr into r unit vector, and using this r dot the r, that's equal to 1. So this is expression for the electric field, and this is the electric potential V. So here the expression for the potential is given by V equal to minus 1 by 4 pi epsilon naught integral infinity to r Q by r square r unit vector into dr r unit vector, and that's equal to minus 1 by 4 pi epsilon naught integral infinity to r Q by r square dr. So after integration, we will get the expression as V equal to minus 1 by 4 pi epsilon naught Q into minus 1 by r, and the lower limit is infinity and the upper limit is r, and that will be equal to 1 by 4 pi epsilon naught Q by r. So the electric potential due to a point charge Q at a distance r is given by V equal to 1 by 4 pi epsilon naught Q by r. So this is the expression for that we are taking it as 1.33. Now we can consider the important points to remember. That is, if the source charge Q is positive, then V is greater than 0, and if Q is negative, then V is also negative. That will be equal to V equal to minus 1 by 4 pi epsilon naught Q by r. The second important point is that the description of motion of objects using the concept of potential or potential energy is simpler than that using the concept of field. So these are the things that you should remember, and the next important thing to remember is that the potential due to a positive charge, that will decrease as the distance increases, but for a negative charge the potential increases as the distance is increased. So at infinity the electrostatic potential is 0, and in the case of a gravitational force, the mass will move from a point of higher gravitational potential to a point of lower gravitational potential. Similarly, in electrostatics, a positive charge will move from a point of higher electrostatic potential to lower electrostatic potential, but the negative charge will move from lower electrostatic potential to higher electrostatic potential. So this is shown in the diagram, that is in 1.24, that is here. You see it in this diagram, the charges moving from higher potential to lower potential, and this is the comparison of gravitational field. So in the case of this diagram, the charges will be moving from higher potential to lower potential, and here the negative charge will move from lower potential to higher potential. Whereas in the case of gravitational field, the masses will move from higher gravitational potential to lower gravitational potential. Now the next important point is that the electric potential at a point P due to a collection of charges Q1, Q2, Q3 and so on up to Qn is equal to the sum of the electric potentials due to individual charges. So this is another important point to remember. So that is the gravitational force and the electric charges that we have considered. Then similarly in the case of electrostatics, the electric potential at a point P due to a collection of charges, a number of charges you can consider as Q1, Q2, Q3 etc. up to Qn, that is equal to the sum of electric potentials due to individual charges. So that's another important point to remember. Then the expression for the total potential that is given by this equation, that is V total will be equal to KQ1 by R1 plus KQ2 by R2 plus KQ3 by R3 and so on, that's up to KQN by Rn. That will be equal to 1 by 4 pi epsilon naught sigma I equal to 1 to n Qi by Ri. So here the variables R1, R2, R3, they are the distances of Q1, Q2, Q3 from the point P. So you can consider this charges, that is Q1, Q2, Q3 etc. separated by the distances R1, R2 and R3. So these are the charges Q1, Q2, Q3, Qn. They are separated from the point P by the distances R1, R2, R3 and Rn. So for this, the total potential, electric potential, that is due to a collection of charges, is given by this expression V total. So that's the thing that you should remember about the charges, the electric potential due to a number of point charges. The next topic that will be discussed in our next video. Thank you.